Well, and actually, yeah, why don't you, can you take it and just maybe go sit in the living room or the piano room or something? Okay, that's fine. Okay. So here we go. Let's take a look. Hey, Nikki, and I know you keep going back and forth, and I'm really sorry. Hey, there's Sky. Hi, Sky.
Hi.
Hey, listen, we were just gonna get started. I was gonna start with number 1. Is that okay, or do you want to? Did you guys do number 1? Was that okay?
Yeah, we can start with 1. I honestly looked at it and I did not really understand a bit of it.
Yeah. Did you guys watch the video that was with the Hess's Law at Khan Academy? Yeah. Okay. Yeah, and that's fine. What my plan is, we'll go through a couple of them, maybe the first 2 to see if we can get the answer to match theirs. And if we do, that's a good sign. And then maybe the other 3 then, if you guys want to try those, and then check back with me like tomorrow and we'll see how it goes. I think the assignment for today, did I assign more? I don't even know. Did I assign anything? Maybe not. Oh, I didn't. Hey, look at us. So anyways, just finish out this assignment then today, and then tomorrow I'll be looking for more practice problems like this. So, okay, here we go. If you got number 1, let me show you what this is. Okay, so can you guys see that on the screen?
Yeah.
Okay. Yeah. So the main thing about using Hess's law is that equation where it says B2H6 plus 6Cl2 yields 2BCl3 plus 6HCl. That's the equation that you're trying to get to ultimately. They said, given the following equations and the H values, which that's enthalpy or heat of reaction, determine the heat of the reaction at 298 for this particular reaction. So they're saying you're going to have to combine all of those other reactions, enthalpies, in order to figure out this one that's in bold print, okay? So what I start out by doing is on my paper, I don't know if you guys can see that. Nikki, Sky, can you see that at all on my paper?
Yes.
Okay. I start by writing down the equation that I want. So this is the one that I want. Ooh, 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 honey. Okay, so my daughter just rolled her eyes at me. It's rude. You've got these equations there at the bottom, those 3 at the bottom. Those are the ones that you're going to try to make look like that equation. So basically now this just turns into, we've got to flip some of the equations, and you're going to have to manipulate these equations in order to get them to look like the one that's in bold. Okay, we're going to use these equations to figure out the heat of the reaction for that equation. Okay, so let's start with the first equation where it says BCl3 plus 3H2O yields H3BO3 plus 3HCl. Is there anything in that equation that would help us get to the equation in bold? Do you see anything in that first equation, in that first reaction that we might want to keep? And I do, by the way. Like, I know that on the product side of that reaction number 1, and I'm going to go ahead and label this because I didn't. I'm going to label this like reaction A. Maybe. This is reaction A. This is just so I don't have to keep saying, look at that reaction, you know, the one, the second one, you know, okay. Okay, so we'll do that. There's reaction B, and then we'll call this one reaction C. Okay, so out of reaction A, see how they have the HCl in the product? I want to keep that in the product. And as a matter of fact, how many HCl's, though, are in the bolded equation? What's the coefficient in that bolded equation? Nikki, do you see it?
6.
Yeah, 6, right? So what we're going to do is I'm going to go ahead and write down equation A, and I'm going to keep it just the way it is. BCl3 plus 3H2O yields H3BO3 plus 3HCl. Now, one thing I wanted to point out, the only states of matter that I'm going to write down are the ones that are different. So everything's a gas except for the water is a liquid. And I'm going to go ahead and write down my enthalpy too over here to the side, and it's a negative 112.5. So I've got that written down like that. don't know if you guys can see that. But now I want it to be 6 HCl's. So on that equation A, I'm gonna have to multiply everything by 2 because I want to have 6 HCl's. So I'm gonna go ahead and just put a coefficient and multiply everything there, all the coefficients by 2. So I'm gonna end up with 2 BCl3, 6 H2O, 2 H3BO3, and 6 HCl. And if you multiply all that by 2, you've also got to multiply your enthalpy by 2 as well. So you are going to need a calculator today, by the way. So that ends up being negative 225 kilojoules, or heat of reaction. It's kilojoules per reaction, but anyway. You see what I got so far? Yep. Okay. All right. So the next thing I'm going to do is so I've got my 6 HCl's out of that equation. So I'm just going to leave that one alone for now. And I'm going to go into equation B, and I'm going to ask myself, is there anything in equation B that I could use to help me get the bolded equation? And Sky, what do you think about equation B? Do you see anything there we could use?
The B2H6.
Yeah, good. So I'm going to just go ahead and write that on my paper, that whole equation, and I'm going to leave it alone. I'm not going to try to multiply it or anything. I'm just going to write that equation down. Plus 6H2O. Excuse me. And I'm going to go ahead and write my enthalpy out to the side too. Okay. And so you'll notice, like, all I've got there is I've written down that equation, and I didn't change anything about that one because I want to leave that B2H6 just alone, because there's one in that equation on letter B, and there's one in the equation that we want. So I'm going to leave that. So then the third equation, I'm going to take that one. And if you look at it, is there anything in that particular equation that we could use for the bolded equation? Nikki, what do you think?
You can probably use the Cl2. You just have to multiply by 3.
Yeah, for sure. Like, we're gonna go ahead and use that Cl2, and also if you notice the HCl on the product side, we're gonna need that as a product as well. Oh, well, no, and I guess maybe not. Anyways, we'll see what we need to do about that. But there are some HCl's over there, so we'll see what we can do about that. So let's go ahead and write that down. So H2 plus yields HCl and negative 92.3. Okay. So we do want to keep that Cl2. Now the thing is, because of the fact that you've got HCl in this equation, but we already kind of got our 6 HCl's, we may have to go back and rearrange or like redo some things, okay? Because we do want to have the BCl3. Oh, okay. So that's going to be a problem. Okay. Sorry, I screwed that up already. So if you go back and you look at, this happens, Maddie, it's science. So if you go back and look at equation A, hey, do you see something in equation A that we're going to need on the product side? Because I do. And it's the BCl3. So what we're going to need to do with that whole equation is we're going to have to flip it. That BCl3 has got to be on the product side. Sorry, messed that up. So now that I've completely screwed you up. Do you understand what I'm saying? So I'm going to flip that equation on letter A. I'm going to flip it around completely. So I'm going to end up, and I'm going to go ahead and keep like, because we multiplied everything times 6, I'm going to go ahead and keep that multiplied by 6. I'm just going to flip it around and do 2H3BO3 plus 6HCl yields 2BCl3 plus 6H2O liquid. And that's going to make that be positive. Whenever you flip an equation around, the enthalpy becomes positive. Okay, so ladies, turn your mics back on and let's discuss this for just a minute.
Okay. I don't even see where you're. Oh, okay. Wait, I see where you are.
Do you see it? Do you understand what I did there? Like I completely did not look ahead, and the BCl3, we're going to need that to be on the product side. So you can just flip that equation around and reverse it.
Yeah, but don't you need the 6HCl on the product side?
Well, and the thing is, though, on reaction C, you do have some hydrofluoric acid. Mm-hmm. So, you know, is it possible that we could get 6 HCl's out of that reaction?
Yeah, but
okay. And so hang with me here, though. That Cl2, we're going to have to get 6 out of that, right?
Mm-hmm.
What would you multiply a half by in order to get 6 Cl2s?
12.
12, right? If we multiply reaction C, all of it by 12, that's going to end up making that be 6H2 plus 6Cl2 yields 12 HCl, right? And I'm going to go ahead and multiply that 92.3, that negative 92.3 by 12. So I end up with negative 1107.6, okay? So this is what I did. I don't know if you can see that. Okay, now here's the thing. What we're going to do is we're going to have to cancel out some stuff because like you said, we don't need 12 HCl's. We really only need 6. And so what you could do, though, is you can start looking at the equation and figuring out what things do I know that I already have, and we can start canceling out other stuff, okay? So I know in this top equation, the one that we want, the one that's bolded, the B2H6, do I have that like from reaction B? And the answer is yes. So I'm going to go ahead and circle mine, telling me that I've got that. Like, this is what I need. Okay. So if you're looking at the bolded equation, the one at the very top, do I have in any of these equations 6Cl2? And Sky, do we have in any of those equations, do we already have 6Cl2? Did she leave? Maybe she went to the bathroom. Nikki, do you see 6Cl2?
Yeah, it's in part C.
Yeah. So all we're going to do is go ahead and circle that. Okay. I know I've got that. So that's good. And then take a look on the right side of the equation. We're going to need 2 BCl3 and 6 HCl. So look at the product side on all 3 of those reactions like A, B, and C. Do we have a 2 BCl3? And the answer is, yeah, we do. Like in a reaction A, right? Mm-hmm. So I'm going to circle that one. That's the one that, oops. That's the one that I've got. And then, do we have 6 HCl somewhere? And the answer is yes, we do. But we're going to have to fix it a little bit, okay? What you can do, if you have HCl that shows up on both sides of the equation, like it's on the reactant side and the product side, you can cancel stuff out. So you have 12 HCl's on the product side, but you have 6 HCl's on the reactant side. So you could actually cancel out 6 of the HCl's on the product side. And that will cancel out all of the HCl's on the reactant side. Does that make sense? Can you see that?
I'm a little confused. Like my dad was talking to me for a minute.
Oh.
I'm completely lost.
Stinking dad.
So,
No, I'm kidding. What I did here is anytime you have HCl or like something that's the same on the reactant and the product side, you can cancel those things out. And the fact that we had 6 HCl's on the reactant side and then you have 12 HCl's on the product side, you can actually cancel out 6 of the 12 on the product side.
Okay.
Okay. Does that make sense?
Yeah.
So I can cancel out the 6 in reaction A. I can get rid of those HCl's. And then on reaction C, I can get rid of 6 HCl's. And so what I'm left with is 6 HCl's. And that's good. That's what I want. Okay. So here's the thing. Like the things that I've circled, I've got everything that I need, right? Like in those like all 4 of those things are the right stuff for that bolded equation. That's what I want, right? Now, the only other thing you've got to do is you've got to make sure that everything else will cancel out. The only way that they can cancel out, though, is they have to show up on the reactant side and the product side, like the correct amounts, too. So, so Nikki or Sky, whoever wants to jump in on this, can I cancel out in reaction A, can I cancel out that H3BO3, the 2 H3BO3?
Yes.
And yeah, and from what? Which reaction?
B.
Yep. So I'm going to go ahead and just cancel those out. I'm just going to draw a scratchy line through them. How about if you're looking at reaction A on the other side, you have 6 H2L liquid. So you have to look for another liquid water. Could I cancel that out?
Wait, are you talking about the H2O?
Yeah, the H2O. What did I say?
Okay, you said H2L, and I was like, what?
Oh, sorry. You know, H2L, it's new.
Yeah.
No, H2O liquid. But the thing is, like, you've got to look for liquid water in one of the other equations. And can I do it? Can I cancel that out?
Yeah, it's on B.
Yeah, so I'm going to go ahead and cancel that out. Okay. And then what's the only thing left that we've got to cancel out?
The hydrogen gas.
Yep, hydrogen. Okay, so I'm going to cancel those out because we got 6 and 6, right? So I end up, it looks like this. It looks like a bunch of scratchy out word, right? Okay. And now at this point, though, I've got everything that I need. And so I'm just going to go ahead and take all those enthalpy values because when I adjusted these reactions, I adjusted the enthalpies as well. And so what you've got to remember when you're using Hess's law, if you have to flip a reaction, it's going to flip the sign on the enthalpy value, okay? If you have to multiply or divide by a number to get the correct coefficient, you're going to have to do the same thing to the enthalpy value, either multiply by that number or divide by that number, okay? But then at the end, it just becomes, you're just going to add all of your enthalpies together, okay? So we should have, from reaction A, 225 kilojoules plus a negative 493.4 plus negative 1107.6. Then let's see what we get. And I got negative 1,376 kilojoules. Were you able to get that? Just like that?
Hold on.
Okay.
I don't know what I did. Oh, that should be a negative. What did you get?
I got negative 1,376.
Yeah, same.
Okay, good. And according to the answer sheet, I went ahead and left the answers on the first couple of problems, whoops, just to make sure that we were going to get the right stuff, okay? And so there's our answer for that one. Okay. Do you want to go ahead and we've got like about probably 20 more minutes. Do you want to go ahead and try number 2 and see what we can come up with? Or do you want to try one of the other ones and we'll work it together?
Either works for me.
Okay. Well, I don't have the answers sitting here in front of me for 3, 4, and 5. I mean, we could try them and see if we got them right. I think our best bet would let's both work on, and Sky, if you're still out there, let's all 3 work on number 2. And do you have the general idea about what you got to do?
I think so.
Well, and that's what we're going to find out. We're going to try it out. And then as we come to questions, like because I'm going to work mine and probably talk to myself. And you work yours. And then as you come upon things, just feel free to shout out like, hey, what am I supposed to do here? Okay. So, okay. So that's what I'm going to do. And you ladies work on that too. And then as you come to questions, holler. Okay. We're doing number 2.
Okay, I have a question. Miss Level, you're muted.
I'm sorry. I having all kinds of issues today. My youngest child just came in and told me it was National Hippo Day, and then they both got a good chuckle and did this. So not been a good morning around here. I'm sorry. Anyway, Sky, what's your question?
Okay, so I'm looking at like the second equation, and I was wondering because there's SF4 and then there's also SO2,
Uh-huh.
and you don't have to do anything to either of them to get what's in the bolded equation. So do you need to like flip it or do anything with it?
Well, and on that one, I ended up flipping it because because I wanted that SF4 to be on the product side.
Okay.
So I think, yeah, let me go back to that. I think on that one, a letter B, I ended up, let's see, SF4. Yeah, so I flipped that equation to take the SF4 and the 2H2O. I put that on the product side and put the other stuff on the reactant side because I wanted it to match up. Now, I see what you're saying though, like the SO2 is over there, but if you look at the next equation on letter C, there's an SO2 there too. So, but the SF4, it only shows up once in all three of these equations. So you know that this is your opportunity to get it on the right side, the correct side.
Okay.
Okay. Now remember though, Sky, whenever you flip that, don't forget to change the sign on the enthalpy value. Instead of having a negative 827, it'll become positive if you reverse it, okay?
Okay.
Okay. Bless you. You should know I unmuted myself.
That was a lot of sneezes.
I know. I'm saying that was a lot of sneezes. Yes, it was. She gets that from my mother. Sometimes we're afraid my mom will flatline because she sneezes like 10 in a row. You know, because they say your heart stops every time you sneeze or like skips a beat or whatever. But yeah, like she gets that from her nana. Anyways, hey, so did you get your final answer?
Yeah.
What'd you get?
I got negative 319.5.
Whoop, whoop. Me too. Sky, how's it going?
It's a little rough, honestly.
Yeah. 2 out of 3 ain't bad. Me and Nikki got it. So no. And I'll tell you though, once you can figure it out, I really like these Hess's law problems because they feel like a puzzle to me. Feels like I'm working on a puzzle. So Sky, so where have you got to so far? What did you do to, sorry.
I've gotten to like right before we're supposed to start like canceling stuff out.
Okay.
But I'm confused.
Okay. Well, let me ask you this. Okay. So like on equation A, did you have to do anything to it?
Yeah, I flipped it and then I multiplied it by 2. Is that right? Or is that wrong?
Well, I don't know that you would have to flip it. Why did you flip it for?
So that, one second, let me pull up the doc with the equations on it. I flipped it so that the OF2 would be on the product side.
Okay, well, and here's the thing. Since in the bolded equation, it's on the reactant side, you want to keep equation A, you want that OF2 to stay on the reactant side. You want it to show up on the left. Now, if you're talking about the three equations, though, and how they relate to each other, sometimes you do want one to be on the reactant, one to be on the product, like in case you have to cancel stuff out. But just looking at equation A and comparing that to the bolded equation, if OF2 shows up in the bolded equation on the reactant side, you want to make sure in equation A that you keep it on the reactant side. So that one you don't need to flip. So we'll put that one, reverse the flip. You want to keep OF2 on the reactant side, but you also, and I don't know if you said this, you may have, you want it to show up as 2 OF2, right?
Yeah.
So you would have to multiply everything there by 2. So
yeah,
did you do that?
I didn't know that I wasn't supposed to flip it.
Yeah.
So
Hey, so
probably
what?
Confused.
Yeah. So what's your enthalpy value for that one on letter A?
553.2.
Yeah, and we're going to go ahead and since we put it back the way it was originally, we're going to go ahead and let that be negative 553.2.
Okay.
Okay. All right. So now that you did that, how about letter B though? What should we do with that one?
I flipped it and then I didn't do anything with it. I just changed the sign.
Yeah, good, perfect. Yeah, you just flip it and change the sign to positive. Good. How about letter C? Did you have to do anything to that one?
No, or I didn't.
Okay, well, what I ended up doing on this one, if I compared it back to the original equation, on that black bolded equation, how many solid sulfurs do you have?
2.
2. So on equation C, then, we want it to also show up the same way. You want that one to show 2 solid sulfurs, right?
Mm-hmm.
Which means that we're going to have to multiply the entire equation. We're going to have to double everything. Okay. So we're going to put a 2 in front of that S, a 2 in front of the O2, and a 2 in front of the SO2, and we're going to have to multiply the enthalpy by 2.
Okay. Does it matter that it changes the SO2 to to 2 of them?
No, and that's okay. That's all right, because we'll see in a minute, that little problem will take care of itself here in just a second.
Okay.
So what did you get for your enthalpy value on letter C?
Negative 593.8.
Good. Okay. Now, the next thing that I would do if I were you is I would go through that equation, the one at the very top, and just start circling in the 3 equations the things that I know that I have that are going to work. Okay. So for the 2OF2, do you have that in one of the equations on the reaction side?
Yeah, it's in the first one.
Yeah. So I would circle that. Okay.
Okay.
And then I would go look for my 2S solid, my 2 sulfur solids. Where's that one at?
In the third one. The third.
Good. So circle that one. We've got that. Now the SO2, do you see SO2?
Yeah.
Yeah, it's on the product side, but it says we have 2 of them, right? And we don't want 2, so we really need to get rid of one of them. So if you look at equation B, there should be, on the reactant side, there should be an SO2 there. Do you see it?
Yeah.
So that one you can use to cancel out one of the SO2s on the product side in reaction C.
Oh, okay.
Okay. And so when you do that, so you get rid of the SO2 in reaction B, it cancels out. And then on reaction C, one of them cancels out. So boom, there you go. You've got what you need. You've got the SO2. So you can circle that is what you've got. Okay. And then finally, do you have SF4?
Yeah, in equation B.
Good. So I circle that, right? And then the next thing you've got to do is you want to go back to reaction A and just start making sure that everything else would cancel out. Okay.
So then after that, do I just...
Yeah, and after that, once you got everything else canceled out, now you can just go and add up all of your enthalpies.
Okay. Okay, cool. There's
Good?
that answer.
Nice.
That made a lot more sense.
Oh, good. Okay. Well, and I guess that's my final question because I'm going to let you guys try the next 3 then. And I've got to do them too. I haven't done them yet. So we'll compare answers and see what we got. But anyways, finish out that assignment. Does it make more sense now? Like what you got to do? Okay. Good. All right. So go ahead and try to finish these out tonight. And then tomorrow you'll have another assignment related to this. Okay. But really that's about it for Hess's law. You know, we may do a little bit of just an enthalpy review, and we might have a little quiz like on Wednesday or Thursday, like just a Google form quiz, and then that'll be it for thermodynamics. So
Do you have the answers to these ones?
I do somewhere on my computer. Like I'll have to go because it was just like, honestly, Nikki, it was just like oh, hey, I'm gonna go ahead and stop recording this. Stop recording.